1770, maximum score from performing multiplication operations. Yeah, let's first try to understand the problem. So we are given an array of nums and another array of multipliers, and this nums is the length of the nums is more than or equal to multipliers. Yeah, so this is also reasonable. Yeah, because we're gonna use the multipliers one by one. So for the first case, for example, we're gonna use 3, and this 3 can multiply by this 3 or this 1 because it must be at the head or the tail of the nums. Yeah, and for the next step, we're gonna choose the second number, and this number will choose the head or tail. Yeah, so for the first example, this 3 would times 3, and then this 2 would times 2, and the last one would times 1. Yeah, and the final answer is 14. And the numbers can be positive or negative numbers. Yeah, we should understand that this is not a greedy problem. Yeah, because maybe you're gonna think we always gonna choose the biggest number, but there is also negative numbers. It is it is not the case. I think it's really easy to find counter examples. Yeah, and this is actually a DP problem. I think for DP it's more safe to solve such kind of a problem. Yeah, so for each of the time we can choose from the head or the tail, and then for the next number we're gonna choose from head or tail, and finally we just need to check the maximum number. Yeah, so for me I'm prefer to use the DFS plus memorization. So for this kind of DP, because this is easy to write for the multi-dimensional DP. Yeah, it's easy to analyze and easy to write. Yeah, I'm gonna prepare a left and right pointer. So this left and right pointer is for the nums, and another one I'm gonna prepare an index. This is for multipliers. So I'm gonna prepare an index. At the same time, I'm going to prepare the m should be equal to the length of the multipliers. Yeah. Now I can start the DFS. Finally, for my return, I'm going to return the DFS with 0 less of nums minus 1. This is from the right side, and the index going to be starting from 0. Yeah. Because this the length of the multipliers is always smaller or equal to length of nums. So for the edge cases, I can directly use the index. If this index is equal to m, I'm gonna return a 0. It means there's no. It means it has already finished the multipliers. There's nothing to do. So I'm gonna return a 0. Now I'm gonna prepare a result. It would be negative infinity. So here for this result, you cannot prepare for 0. Yeah, because for the first calculation, it might be a negative number, but you cannot update it to 0. So this is why we're going to always choose the negative infinity, because there's negative numbers. If there's no negative numbers, yeah, maybe you can try to put the result as 0. Yeah. Now we're gonna prepare. Yes, we just need to check the nums. So the nums can go from the left or right side. So what is it gonna be? So it would be maximum of result. Yeah, let's first try the left side because we don't know. So if we choose from the left side, what is it gonna be? It's gonna be nums L times the multiplier. Yeah, the multiplier's index. Yeah, we get the result and plus the DFS. So the DFS would be because L has already been calculated and it should be removed. Yeah. According to the question, it should be removed, so it should be L plus 1, and the R would be the same, and inside the index should plus 1 because it need to go to the next multiplier. Yeah. Now let's go to let's continue to check another side. Check the right side. If we choose the right side, it's gonna be nums R, and the multipliers gonna still be the same. Yeah. And here gonna be L. And here gonna be R plus 1. Yeah, actually this is the entire code. As you can see that it is not so difficult because we just use DFS plus memorization. Yeah. Now let me run it to check. Yeah, it is a non-type. Yeah, let me just check what is wrong with it. Unspotted types plus int and non-type. So this means my DFS, there is a non-type for the DFS. Yeah, because here I did something wrong. It should be r minus 1. Yeah, because the right pointer should be shifted to the left. It's not r plus 1. Let me just run it again. It's the same. L should plus 1. Nums L times DFS L plus 1 R index plus 1, and the result with nums R times multipliers index and index plus 1. Yeah, this is strings. Normally I should not make such kind of a mistake. Yeah, this is a DFS L plus 1 R index. Oh, I don't know. Yeah, I get a int and a non-type. Definitely this gonna be an int. Yeah, if this index equal to m, I'm gonna return 0. Yeah, let me just delete. I don't know why I make such a mistake. Let me just start again. So the result would be negative infinity, and I will update my result. It should be maximum of the result. With the left side, it would be nums L times the multipliers with the index 0 and plus DFS. It should be L should plus 1 and R, and inside it should be index plus 1. Yeah. So what's gonna happen if I don't write the second line? Yeah, it is still something wrong with it. I don't know why. Yeah, normally I think if I write it for the first time, for the second time I should not make a mistake, because for the first time I didn't make a mistake. This is the strings r minus 1. Yeah, because I didn't return the result. Yeah, so now I think it should be okay. Yeah, because for each of the time I should return the result. Now at least, yeah, at least the program works, but I got the wrong answer. For the first time it is a 10, and this is yeah, not right. Let me just check what is wrong with it. So yeah, because I'm gonna choose the maximum number. This is a negative infinity, and yeah, this one I didn't change it. I need to change it to R, and now let's just check it. Yeah, now as you can see it works. Now let me submit it to check if it can pass for all testing cases. Now as you can see it passed for all testing cases. Yeah, I should be more careful about it. So sometimes if I just use the copy and paste, I will forget about something. And for this time I even forget about the return. The time complexity is O n times m. Although you can see here there are 3 indexes, actually for this L and R, it's gonna always be smaller and smaller. This is just like a 2-pointer, because L will always be shifted to the right, R will always be shifted to the left. So this is actually On. And for the index, so this is Om. So the time complexity is Om times n. Yeah, because we use the cache, we use the memorization, so that is why it can pass. And let's check the n and m. So the m is 300, and n is the num's length is 10 to the power of 5. So this means 3 times 10 to the power of 7 can pass for this kind of a problem. Thank you for watching. See you next time.